This is a linear power boost, one of the first pedals or effects to be made for a guitar. It's a single transistor amplifier that cuts the bass and then amplifies what's left, i.e. treble boost. So there's only one control, and that is controlling how much signal goes to the output of the pedal. And then on the input we have a capacitor essentially, which attenuates the bass, and that's how we get treble boost. Actually, it's called a linear power booster, linear power booster 1, and it wasn't always a pedal. It was an inline device that would go between your guitar cable or amplifier, depending where you want to put it. Some people put it at the guitar end, and so you would get a better matched signal going all the way through the long cable to the amplifier. And some people put it at the amplifier to boost the treble. You can use it either way. This is going to go at the start of the signal chain on the board I'm going to build. So I want to do a couple of things. Even though it has an high impedance input, I'd like to isolate the circuit a little more from the rest of the world. So I'm going to put op-amp buffer. I'm touching here because I think this is where I'm going to put it once I open it up. So I'm going to put an op-amp buffer inside it. And then also on a video I made, I converted an Electro Harmonix Big Muff into a clean boost. I called it a warm boost because it was terrifically warm. You know, the Big Muff has it's got a very low frequency response. So I'd like to add elements of that into this pedal so I can have a little switch and be able to have it as a standard linear power booster, or what I would call a warm boost, which is essentially the first circuit in the 4 gain stages of a Big Muff. And that first circuit in those 4 gain stages of the Big Muff looks almost like the linear power boost circuit, and we'll go into that when we get into the schematic review. But so first of all, let's take this thing apart. So we got the top off. First observation is that it's all through hole like the original. This section here is new. A lot of the schematics on the internet don't cover this, but there's a ferrite choke there, cap and reverse polarity diode to protect it, and filter for modern signals like cell phones and all the electronic gadgets we have nowadays that can add clock noise to a high gain device like this. There's our transistor and the relevant capacitors and resistors. So I'm going to get the scope on this in a minute and try and trace it out. But I want to remove the battery because we're not going to use the battery. And this has got a mic battery. I love these things. Just take that out. But isn't that the coolest thing ever? One day people will make batteries with my picture on. Right, let's get to it. Here's our schematic. So it's a 2N5088 transistor. The gain is set by this 10K and this 390 and the bias, and the input impedance is managed by this 1 meg and this 100K, and then this 1 meg here stops the pop when you switch it in and out. This 100 nanofarad is key because this is our bass suppressor. So this is a high pass filter, or this network around here forms a high pass filter. So only the higher frequencies get to the transistor, and then that's what's amplified, and then it goes out. This value is the same as this value, but I think you could make that into 1 microfarad if you want, but don't quote me on that. And then it goes to the output, and then we control the volume of the output with that single volume here. So that is that guy. Now if we go over to the Big Muff, this is the input stage here. Slightly different schematic, but it's worth having a look at. And so we have a 10K here and a 120 here. So this controls the gain. So if we go back, the gain on this is a little lower than the gain on this. And what I'm going to do is probably leave these 2 resistors in place, but I'm going to add this filter network, negative feedback filter network here to the pedal, which is this thing here. Here's the transistor. This is the 10K that goes to the collector. This is the 390K that goes on the emitter. And then these two guys here are connected to the base, and the input signal arrives here probably through this capacitor, but I haven't checked yet with the scope. So I think what we have to do is, well, actually we don't have to lift that, but we're going to solder a wire on here, and we're going to solder a wire on here. And then the schematic I showed you earlier, this was a 1 meg and this was 100K. In this is a 430K, and this is a 430K, and this is the 34K. And different values, but same ratio, and it's the ratio that counts when we do the biasing. So I think the first job is to solder two wires, one wire here and one wire here, and this is going to be our negative, our filtered negative feedback loop, and then we can start playing with some capacitors. I've got it hooked up to the signal generator, so this is the input signal, this is the output signal. Here's the switch that we're going to switch it on and off, and behind this blank part on the PCB, that is where the one single volume pot is that we're going to adjust when we look at it on the scope. I've got one channel set completely to the output, and then another channel of the scope. We've got the probe here so we can probe around. Let's take a look at the scope. The green is the output signal, and the yellow, let me touch it here on the tip of the jack. There it is, that's the input. Some noise creeping in somewhere, but that's all filtered out. So I'll turn it up, full blast, adjust the amplitude on the scope. Looks clipping. So I've got 300 millivolts as my input signal, which I always think is typically of a low gain guitar. Bring it down to 200, 100, nice and clean. Starts to clip around 150, it looks like. Yeah, it just starts to clip, I should say, at that value. So that's with the thing turned up full. So this thing will introduce distortion. Probably nice to put some kind of expression pedal in front of it, or a volume pedal, to ensure we get a nice clean signal. The output, this is full blast. The output is, so we've got the scope set to 1 volt peak to peak. So let's just put this so it touches. So we got 1, 2, 3, 4, 5. So the maximum output voltage is going to be 5 volts peak to peak. Now let me just put the probe on the center pin of the transistor, if I can find it. That's the signal after the filter cap and the input resistor, and then that's the signal on the collector. So that's the amplified signal before it goes through the output capacitor and ultimately the volume pot. So we're getting an idea of how this thing works. What I'm going to do is lift R4, put that network in there. Well, I'm actually going to probably take a wire from the lifted leg of R4 here, the lifted leg of R4 here, and then put a wire in the hole, and then we're going to add a switch and that RC network so we can put some negative feedback into the system. After some rewiring, I've put it all back together. So here is the cap and resistor network that's going to create some negative feedback for higher frequencies. So this will dull some of the sparkliness of the pedal. And while I was at it, I actually decided, because this is the first pedal on the pedal board, to put a buffer in. So it's a hand wired TL071. op amp underneath that hot glue, and it's biased correctly and everything. So I've got a on-off switch here for the bias, not for the bias, for the preamp, for the buffer. And then here on the front, this is where, so that's bass cut. Sorry, that is normal, and that is high cut there. So it's looking good. I'm trying to put this knob on. Oh, I need to get it on the right way. Oh, now it's stuck. All right, let's try and get this, turn that all the way down. Place that on there like that. Yep, looks good. Fantastic. Let's do some tests. I think the first measurement I'm going to do now we have this thing assembled is to check the voltage on the collector of the transistor, because we saw clipping even with a small signal, you know, that was representative of a single coil pickup around 300 millivolts, 1 kilohertz sine wave, that clipped. So I'm going to measure the collector voltage here, and it should be about 4.5 volts if it's biased correctly. And I'm reading 5.96 volts. So we have an issue. We could do a better job on biasing this and moving more of the signal into the linear operating range of the amplifier. So why don't we actually put a trim pot here of 10k, reduce this to a 5k, so that gives us 15k of total change with a minimum of 5 and a maximum of 15, and let's see if we can get that voltage down to something more closer to 4.5 volts, which is what it should be ideally. So I've got a trim pot, value 10k, replace the 10k resistor here with a 5k resistor, put some shrink wrap around it, put some hot glue in there as well to make sure it can stand many bumps and bashes over its years it's going to be in service. And then the pot and the resistor give a combined overall resistance of 15k, but if we turn it all the way down it's going to be 5k. If we turn it all the way up it's going to be 15k. So if we just stick the probe on here, I think, if I can get in there, yeah, and so I'm measuring 5.5 volts. So we'll just put this in here and move it in this direction. So that's about 4.5. So let's put the scope on it now. If we just observe on the scope, and this is set at 4.5 volts, and increase it, we can see the clipping. So I'm just going to pull it back till we get a nice sine wave, so we're maximizing the headroom, and we're on 1 volt per division. So that's 1, 2, 3, 4, 5, 6 and a bit volts. So I think we've optimized the circuit a little bit there. So that should be a nice clean boost. So let's do some tone tests with the guitar now. Let's put it all back together and do some tone tests.